Okay, this is the next question. Let f and g be continuous functions of a real variable such that g of x is equal to integral 0 to x f of y negative x times dy for all x. If g is 3 times continuously differentiable, what is the greatest integer n for which f must be n times continuously differentiable? Okay, so they're asking us how many times the f should be differentiable so that we are able to get g triple dash. So that is a simple question. So foremost, let me write g of x. G of x is integral 0 to x f of y negative x times dy. Now we have to differentiate g dash of x. Now for this we use Leibniz rule. Okay, so that is going to be f of x times x negative x times the differentiation of x negative f of 0, right, times 0 negative x. Okay, now this is followed by integral 0 to x d over dx of f of y times y negative x times dy. Now y, because the integrand has the presence of the variable x. Okay, so that is the reason we need to add this. Of course this goes off and this also goes off, so you are left with g dash of x is equal to 0 to x d over dx of f of y times y negative x times dy. This is what you have got. Now what you have to do now is to differentiate this with reference to x. So this is 0 to x, you differentiate this, you get negative 1, right? So that means you have negative f of y times dy is equal to g dash of x. Now you apply Leibniz rule again, so g double dash of x is equal to negative f of x. This is what you are getting. Now you have to get g triple dash, right? So g triple dash of x is going to be negative f dash of x. So this is the final solution. But we have to conclude here. So how do we conclude? So clearly g triple dash of x exists, right, and is continuous. Also we have negative f dash of x with the requirement that f dash of x should exist. Okay, of course f is continuous, right? So it should exist and continuous. Okay, for this to happen, f of x must exist. Okay, and be continuous. Now when is this possible? Okay, f of x should be differentiable at least once. Now this is explanation, you don't have to complicate yourself. The only requirement here is this f dash of x should exist and it has to be continuous, right? Now for this to exist, because only if f dash of x exists, g triple dash of x is going to be existing. So for this to exist, this has to exist, right? And this should be differentiable. So the requirement is how many times this has to be differentiable to acquire this, to reach this point. So it should be differentiable at least once. So that's a basic understanding. If f of x is not going to be differentiable, you will not arrive at g triple dash. This is not going to be existing. So at least once should be the solution for this question. Okay, I hope you got that.